All right, good morning. So we're going to talk about chapter 11.4, which is the last section that we're going to cover. But first, we're going to get into these SAT questions. So the first question, it says a startup company opened with 8 employees. The company's growth plan assumes that 2 new employees will be hired each quarter every 3 months for the first 5 years. If an equation is written in the form of y equals ax plus b to represent the number of employees y employed by the company x quarters after the company opened, what is the value of b? So this is just a interpreting what this is question. So if you look at this should look familiar from Algebra 1 and our class Algebra 2, as that's the y equals mx plus b. So in that equation, we know that certain things. So this is the slope, and we also know this as the y-intercept. So when we talk about this, like slope also can be referred to as the rate of change, right? So we're talking about this company's rate of change is 2 new employees per quarter. So in this particular equation, A would probably be 2, and B would represent the number of employees that were there in the beginning, and X would represent the number of quarters. So this, obviously Y is the total number of employees. So if the total number of employees is growing at a rate of 2 per quarter, right? A being 2, X being the number of quarters, B would be the starting number of employees. So if you want the Y to represent the total number of employees, then B represents, we'll write this down, so B equals the total, the employees at the start, right? So how many employees were there to begin with before this company growth plan was created? All right, so let's go left to right here. So you got this circle, and you got a central angle x degrees. It says note figure not drawn to scale, but it says the circle above point A is the center, and the length of arc BC is 2/5 of the circumference of the circle. What is the value of x? So this is kind of a good one. It gets at the idea of some of the ideas we've been talking about with circle graphs, which is that if this is 2/5, highlight, sorry. So if this is 2/5 of the whole circle, then that's going to be basically, and we know something from geometry, we know that the central angle equals the measure of the arc, right? So measure of, we call it the intercepted arc. So intercepted arc. So this is something that you probably remember from geometry. But whatever this is, say it's equal to 100, like this is going to be the same. So if BC is 2/5 the circumference of the circle, then x degrees is 2/5 of the full way around the circle. So in our case, the full way around the circle is 360 degrees. So basically the question is no more than what is 2/5 of 360 degrees, because that angle is going to be the same. So 2/5 of 360, you can do this in your calculator. It's going to be 144. You type it in, 2 over 5 times 360, it gives me 144, so the value of x would be 144 degrees, right? So that's the answer to number 2 there. All right, then the last one looks like a system. So straight off the bat, I take a glance at it, and I'm like, this looks like a system of equations. And obviously it says xy satisfies the system. What is the value of y? So this system is actually really, really nicely set up for the solving system strategy called the elimination. Why I know that is because I look at the x's and they are already opposites, right? So right away I'm like, I can just combine these 2 equations straight down and get rid of x. So I'm just going to rewrite it down here to make it easier to work with, but I can see already that this is a pretty easy elimination question. So if I add straight down, the x's cancel, y and 3y make 4y, and then negative 3.5 plus 9.5 is going to be 6. So it's not going to be a pretty answer to y, but that's okay. So 6 over 4 reduces, you can take a 2 out of top and bottom, so that's 3 halves. If this was a grid-in answer on the SAT, you could write 3/2, you could write 1.5, you could write that in a few different ways and still get the same credit. So back to the first one, it says B. What was B representing? B was the number of employees at the start, at the onset of the growth plan, and so on and so forth. So that was the SAT questions. Let's get into this lesson. All right, so the first thing we're talking about is like whether your sample that you're looking at is biased or unbiased. So if you think about maybe where you've heard those words before, I'm going to explain it in about 2 seconds, but if you want to pause it for a second, think about like what that might mean, kind of get a prediction. You could pause right now. All right, if you did pause and you came back, let's talk about what these things mean. So the easiest way to explain biased versus unbiased is by using an example. So if I want to make a claim about the total population of Americans, right, and I want to figure out, how many people like Donald Trump, right? What is the percentage of the population that approve of Donald Trump? If I go to a NRA meeting, I'm going to probably get a biased sample of the population of the United States. My sample is not going to be representing the entire population of the United States. It's going to represent a smaller population. I would imagine that the people in the NRA would be very supportive of Donald Trump. I think that his approval rating would look very different if I only sampled the people that were members of the NRA, right? So this is where you think about like a bias sample. So that would be a bias sample. So when we make a prediction based on a sample of people, we want that sample to be as unbiased as possible and as representative of the entire population. So that's literally what a biased sample is. A biased sample is a sample that is not representative of the entire population. So if you're going to make conclusions about a population, you want an unbiased sample so that you can make the most valid conclusion. So an unbiased sample is obviously a sample, that represents. So a sample that does represent. The population that you're trying to make inferences about. So like, for example, if we're talking about the Donald Trump example, if I want to figure out what his approval rating is, I want to sample people from the NRA, I want to sample people from, the ACLU, I want to sample people from all ends of the spectrum, middle, left, right, everywhere, so that I get a clear picture of what the entire population thinks. And that would be an unbiased sample, and that would give me a better feel. All right, so look at some of these examples and try to determine, really, these are just yes or no questions. So I'll give you a second. You could read these, and then we'll come back and talk about whether they're unbiased or biased. So if you paused and read, looking at number 1, it says the town council wants to know if residents support having an off-leash area for dogs in the park. 80 dog owners are surveyed at the park. Is that a biased or unbiased sample? So you clearly see that if you want to figure out that residents of the town, if they support a dog park, you don't want to just interview the people that own dogs, right? You want to interview the entire population. So this is a biased sample. And you can make this unbiased by interviewing more people, right? You got 80 dog owners surveyed. You can interview some dog owners, interview non-dog owners, but you want to have a balance, right? So this is a biased sample because it's not representative. This is all dog owners, right? So of course, if you're surveying these people, you'd probably get a different feel than if you surveyed the whole population. All right, number 2 says the staff for a student newsletter wants to conduct a survey of students' favorite TV shows. There are 1,225 students, and the news staff wants to survey 250. It says describe a method for selecting an unbiased random sample of students. So yeah, this one, if you want to survey students' favorite TV shows, you get 1,225 students, just random sample. So you could just pick names out of a hat. There's different ways to do this, but to make an unbiased random sample, you have to randomize selection, right? You can't just go into one classroom, right? You got to go in and take the 1,225 students and just random pick numbers, right? Because you don't want to pick all the kids from one class. Like you might find that students that all take this one class really like this one show, and that might give you a biased result. So you want to randomize your selection however that looks, pick names out of a hat, however you can do that. All right, so that leads us to the next thing, which is within a sample, there's always some error because you can't take everybody's opinion in the population. You have to consider the fact that a sample is representative of the whole population. So within that, there is some error. So a very simple way to determine that error is take the size of your sample, and the margin of error is determined by plugging the size of the sample in here. So then margin of error is one of those things you've probably heard of. So when you're talking about a survey of likely voters and how many people go for Joe Biden or how many people go for Bernie Sanders or something like that, there's always a margin of error. So if they say the margin of error is 3%, then they're talking about that if 40% of people like Joe Biden and the margin of error is 3%, then what that's actually saying is they don't know if it's 37%, so 3 less than 40, or 43%, or 3 more than 40. We say 40% with a margin of error of 3%. So within the margin of error is where a lot of surveys sort of fall short of predicting exactly what's going to happen. So really the first question is just asking you to find the margin of error using this formula. So this is pretty straightforward stuff. So going through number 3, margin of error, we'll just call it M. So I'm using the formula exactly like it looks, equals plus or minus 1 over the square root of 1,000, right? So the sample size is 1,000 people. The margin of error, given that sample size, the really simple formula for this is plus or minus 1 over square root of 1,000. So square root of 1,000, you put that into your calculator. So square root of 1,000 is 31.6227, and then I take 1 divided by that. So the margin of error is plus or minus 0.0316. And what you're going to start to notice, so this is 3.16% margin of error. So that means on either side, you could add 3.16 or subtract 3.16. So what you're going to notice is as you get bigger samples, the margin of error decreases, right? So the bigger the sample, the smaller the margin of error. So pause this, try number 4, and we'll come back and do it. All right, so hopefully you tried it. Looking at the margin of error for a sample of 750 people, it's plus or minus 1 over root 750. So you do go through the work, and it gives you a margin of error plus or minus 3.65%. So we're going to talk about how to work with that margin of error. But you notice that because it was a little bit of a smaller sample, you have a little bit larger margin of error, right? So the smaller the sample, the bigger the margin of error. All right, so looking at these are more examples. So find the sample size given the margin of error. So now it's the same kind of question. Using that formula, let's figure out what the actual sample size was. So if my margin of error is 3%, so using this formula, m equals 1 over root n, n being the number of people, m being the margin of error, I take 3%, which I got to put that in decimal form because we know that when we did the problem a second ago, the margin of error was given to me as a decimal. So I get 1 over root n. So to solve, really simply, you just multiply both sides by root n. I get 0.03 root n equals 1. Divide by 0.03. So I got root n equals 1 divided by 0.03. So in my calculator, I get 33.3 repeating. And then to get rid of the root, remember we're doing this, just finished a unit on this, you square both sides. So n equals 33 and a third squared. So 33.333 squared gives me a sample I can say is 1,111.1. So obviously probably just about 1,111 if you want to round to the nearest whole number. So it asks us to round to the nearest whole number because it doesn't make sense for samples to be decimals. So about 1,111 people would be my sample size. So pause it, try number 6 here. So a sample margin of error of 5.6%. So just kind of real fast before we get into it, think about, is that sample going to be bigger or smaller than 1,111? So you should have an answer there. So I'll just pause it and then we'll come back with the answer. All right, so I worked it out for you. So a sample size of 319 surveyed people will give you a margin of error of 5.6%. So going through the work real fast, you plug in your margin of error and you solve for n, multiply by root n, divide by 0.056, and and then you square both sides. You get 318.87, which rounds to the nearest whole number would be 319 people. So again, hopefully you thought, yeah, it's got to be a smaller sample, right? The bigger the margin of error, the smaller the sample. So obviously, if you survey more people, you're going to be more sure you're going to have less error. So that's the idea, right? So that's with margin of error. So hopefully if you're getting something out of this, it's that the bigger the sample of people, the smaller the error becomes. All right, so number 7. In a local election, likely voters said they'd vote for J.J. Bittenbinder, 44%, because they thought he had street smarts. Likely voters went for his opponent, Dane Sanzenbacher, for 47% of the time. Every sample has a margin of error, right? What margin of error would make you confident that Dane Sanzenbacher would win the election? How many people would need to have sampled to get that margin of error? So this is kind of like a good question. It kind of gets into what margin of error is. So if I want to be sure that Dane Sanzenbacher is going to win the election, I need a margin of error. So if I got so JJ Bittenbinder, it looks like gets 44% or 45% of the vote. And then Dane Sanzenbacher has 47% of the vote. So let's think about margin of error. If the margin of error is 2%, right? So if the margin of error was 2%, then JJ could actually be anywhere from 43 to 47%. And again, how does that make sense? Well, all I did to find that was if I had a margin of error of 2%, I'd add 2 or subtract 2 from 45. So that means like because there's a margin of error, you're not sure that it's 45. You're sure you're kind of like it is 45, but based on the sample, I know that it could be anywhere between here. And that, with that same sample, Dane Sanzenbacher's margin of error would be anywhere from 45 to 49%. So that overlap, you notice like, so really there is a chance with a 2% margin of error that JJ has 47% of the people and Dane has 45. So if you want to be sure that Dane Sanzenbacher is going to win, you need a smaller margin of error than 2%. So let's try a 1% margin of error. So let's think about it. So if I take and I reduce my margin of error from 2% to 1%, so that makes JJ land between 44 and 46, right? Plus or minus. So I add 1 to 45 or subtract 1 from 45. Same thing with Dane. I'm going to add or subtract 1 from 47. So 47, I'm going to be between 46 and 48. So I'm fairly confident that Dane, because there's really no way JJ can be above 46 in this case, and there's no way that Dane can be below 46. So at the very least, they're going to be like really, really close to tying. So I'm going to say my margin of error that I need is I need at most 1%, hopefully less than that, right? So how many people would you need to survey to get a margin of error of 1%? We just did that, right? So if the margin of error is 1%, I'm solving this equation, right? How many people need to be surveyed? So figuring that out, I mean, you could pause it and figure it out yourself. But the big idea here is margin of error, you add and subtract. So if the margin of error is 1%, I add 1% to 47, and I subtract it, and that gives me the range of values you could possibly get. So try this one. You can pause it, work it out. I'm going to finish it in a second. All right, so working it out, I found that I need a sample of 10,000 people to get a margin of error of 1% or less. So I need 10,000 or more people to be sure that these percentages will hold up. So the margin of error needed is 1% or less. The sample is 10,000 people or more. So kind of thinking about that, hopefully that one makes sense. It's a good question. It's a good one to get you thinking about how margin of error plays into just general statistics and everyday life. All right, number 8, a random sample. So this is an SAT question. You can see by the different font here. But this is a random sample of 35 four-door passenger vehicles had a mean gas mileage in miles per gallon of 25.9 miles per gallon. The estimate had a margin of error of 2.6 miles per gallon at a 98% confidence level. Of the following, which is the most plausible value for the true mean gas mileage for all four-door passenger vehicles? So this is kind of like a good question, kind of thinking about what a margin of error means. So there's a lot going on with this question. It says it is 2.6% at a 98% confidence level. So I'm just going to go ahead right away and just, that doesn't really have any bearing on this. That's why I threw it at you, because we haven't talked about confidence levels, and that's more of like a higher level stats kind of thing. But I want to talk about the margin of error being 2.6 miles per gallon. So if the average is 25.9 miles per gallon with a 2.6 miles per gallon level of uncertainty, I got to think about what the range of miles are. So what is 25.9 minus 2.6? Well, that would be 23. So on the low end, within the margin of error, I know that the average could be about 23.3 miles per gallon. And if I add 2.6 to 25.9, I'm on the high end of miles per gallon. I'm at 28.5 miles per gallon. So I'm thinking about just using my margin of error to determine like what my range would be. So in this case, I got a range of 23.3 to 28.5. So looking at these 4 choices, the only one that even falls within that range is, it looks like A. B actually is outside of it, right? So B is outside, it's too big. 29 is too much. 32 and 35 are too much. So the only one that even falls within the margin of error is 24 miles per gallon. So out of the choices, which of the following would have the most plausible answer? It would be A. Number 9, I'm going to give you guys a chance to read it, and we'll pause and come back and explain it. All right, so looking at this one, you got a random samples of river heights. Oceanographers estimate that 4,800 cubic kilometers of fresh water is discharged into the Atlantic Arctic Ocean annually. This estimate has a margin of error of 240 cubic kilometers at a 90% confidence level. Again, the 90% confidence level doesn't have any effect. That's kind of there to confuse you, but the margin of error is important. So the idea of margin of error in this problem is like, okay, 4,800 is what I expect, but I got a margin of error of 240. So I got 240 on either side of 4,800. So I subtract 240 and I add 240, and I see that the total number of gallons or cubic kilometers of water dumped into the Arctic Ocean is going to be between 5,000 or 4,560 and 5,040. So that's the idea there. All right, so you can try this homework, and I'll post the answers. But hopefully this video helped you, and hopefully the margin of error makes sense. Give the homework a try, give the work a try, see if you can figure this out. There's going to be some IXLs possibly too. Your teacher might assign those, but margin of error, it's a very important idea in statistics and just understanding the world.